press the bell icon on the YouTube app and never miss another update.
Hello students, we discuss one more new chapter, probability. Very easy chapter, very important chapter. Before we start second PUC concept, firstly means once again we see the first PUC topic. Why sir? If you know very well in first PUC concept, then it is very easy this concept, because first PUC topics are the foundation for second PUC concept. That's why today class I discuss first PUC concept. Please don't neglect, carefully observe the concept and perfect the concept. In the next class onwards we start second PUC concept. Okay, so don't neglect it, observe carefully each concept, very important. Okay, so first concept, random experiment. You know already, random experiment. Random experiment, it means what? Okay now, random experiment means what? An experiment is said to be random experiment. It satisfies two conditions. An experiment, what my point? An experiment is what? Said to be random experiment. It satisfies two conditions. Condition number one, more than one outcomes. More than one outcomes. We cannot get only one outcome. If we got only one outcome, then that experiment we can't say it is a random experiment. Got my point? More than means the experiment gets more than one outcomes. If the outcome is only one, then we can't say it is a random experiment. This is the first point. The second point, we cannot predict outcomes in advance. We cannot predict the outcomes in advance. This is very important. We cannot predict the outcomes in advance. If these two conditions are satisfied, such experiment we call it as random experiment. That is very important. An experiment, once again I say that an experiment is said to be random experiment. An experiment is said to be random experiment. It satisfies two conditions according to the me. Okay, it satisfies two conditions. The condition number one, it contains more than one outcomes. That is very important. It contains more than one outcomes. The condition number two, very important. The condition number two, we cannot predict the outcomes in advance. We cannot predict the outcomes in advance. So give me the example. You know very well you know, tossing a coin. The outcomes are head and tail. If you toss a coin, we cannot predict head comes, tail comes, that we don't know. After completing the experiment, then only we know that the outcomes. And it contains more than one outcomes, head and tail. Throwing a die. So the outcomes are 6. 1, 2, 3, 4, 5, 6. So if you throw the die, we cannot predict which number. After the completing the experiment, then only we see that which number we got. Understand? So random experiment means it has more than one outcomes, and we cannot predict the outcomes in advance such experiment. So taking a card from a well shuffled pack of 52 playing cards, if you take a card from a well shuffled pack of 52 playing cards, so that you know very well 52 playing cards. So such experiment we call it as what? Random experiment. After knowing the concept of random experiment, one more very important concept, sample space. This is very important. Sample space. So very well know about this one. Today I discuss this concept, because if you know very well about sample space, then probability is very easy. If you write the sample space, probability chapter is completed. That is why observe very carefully. Okay, sample space, no, you already know this one also. The total number of means or else the set of all possible outcomes, the set of all possible outcomes, the set of all possible outcomes are called what? Sample space. Correct? The set of all possible outcomes, or else, in very simple manner, if I want to say, the total number of possible outcomes, we call it as sample space. So usually the set we represented by yes, and each outcomes in sample space, are called sample point. Each outcome, very important, each outcomes, or else the elements present in sample space, So the elements are nothing but what? The outcomes of the random experiment. Correct? Means sample space means it is a set which contains the total possible outcomes. Then each element in the sample space set are called what? Sample point. For example, tossing a coin. The sample space are head and tail. Tossing a coin. Correct? Tossing a coin, the possible outcomes are head and tail. So these two outcomes are called sample point. These two outcomes are called what? Sample point. Sample space, it is a set of all possible outcomes, very important, of all possible what? Outcomes. This is very important, of all possible outcomes in a random experiment. All possible outcomes we write in the form of a set, then that set we call it as what? Sample space. All possible outcomes, once again I say that all possible outcomes are represented in the form of a set, are are called what? Sample space. Usually the sample space are denoted by what? S. The sample space are denoted by S, and the elements which are present in the sample space, the elements which are present in the sample space are called what? Sample point. Better what we do, we try to solve some problems. That means, suppose one experiment he has given, random experiment. What we do, we seeing the random experiment, we write the sample space, because this concept is very important. Writing the sample space, writing the elements in the sample space, that is very important. So okay, we better what we do, we solve some problems regarding sample space, that already you know in first PUC. Okay, that already know in first PUC. The one by one. So I write the question first. Describe the sample space for the given experiment. Describe the sample space for the given random experiment. So no need to write and no need to write, and better today class it is for your observation class. Observe. Okay, very important concept, don't to be neglect. Next class onwards we start second PUC topic. Describe the sample space for the given experiment. The first problem in that, a coin is tossed 3 times. A coin is tossed 3 times. A coin is tossed 3 times. Okay, very well you know about how to write the sample space. See, observe here. Before write the elements, okay, I write the tree structure. If you toss a coin for time, the possible outcomes are head and tail. The possible outcomes are head and tail. This is the first time if you toss. Then if you toss second time, the possible outcomes head tail, as well as if you toss a coin 2 times, the possible outcomes are head tail, tail head, tail tail, tail tail, tail head, tail tail. This is first time. If you toss a coin second time, the possible outcomes are head tail, tail head, tail tail. If you toss a coin 3 times, because he has given a coin is tossed 3 times, then the possible outcomes are, better we write the tree structure, head tail, correct, head tail, head tail, head tail, tail. This regarding 4 elements, 4 sample point, head tail, head tail, head, head, tail, head, tail, tail. In these four sample point, head should be the first element, first place, head. If the first place is tail, then tail, head, tail, head, tail. Correct. So tail, head, tail. Why I write the tree structure? If you write the tree structure, this is very important tree structure. Then no need to buy it and no need to remember, not at all. Simply first time head and tail, second time head, tail, head, tail, tail. Third time head, tail, head, tail, tail, head, tail, head, tail. Okay, then write the sample space. So sample space are usually denoted by S. S is equal to, because all the sample space are represented by a set. Correct? So S is equal to, sample space S is equal to first sample point head, comma, second sample points head, tail, third sample point head, tail, head, fourth one head, tail, head, tail, comma, right below, tail, head, tail, head, tail, head, and all three are tails. All three are tails. So, how many elements are there? 8 elements. N of S is equal to 8. N of S is equal to what? 8. N of S is equal to 8. This is about the sample space for the given experiment. The given experiment is a coin is tossed 3 times. If a coin is tossed 3 times, the total number of outcomes in the sample space is 8. This number is very important for the probability. The total number of sample space is what? It is 8. I think see the problem. Next problem. Next, second problem. A coin is tossed 4 times. A coin is tossed 4 times write the sample space. But also you know. So for better, what we do, we write the tree structure. Firstly, we write the tree structure. First time, if a coin is tossed first time, head and tail. The possible outcomes. If a coin is tossed one time, okay, the possible outcomes are head and tail. If a coin is tossed two times, the possible outcomes are head, 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 tail, tail, head, tail, tail. If a coin is tossed two times, the possible outcomes are head, 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 tail, tail, head, tail, tail. Two times. Then next, if a coin is tossed three times, just now we write the possible outcomes are head, 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 tail, head, tail, head, tail, 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 head, head, tail, head, tail, 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 head, tail, tail. If a coin is tossed, three times, the possible outcomes are like this. Suppose if a coin is tossed four times, head, 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 tail, head, head, tail, head, 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 tail, tail, then head, tail, head, 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 tail, head, tail, head, tail, tail, head, head, tail, 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 like that. Okay, we write the sample space of the experiment. The sample space is given by S is equal to first one, all four are head, correct. Second one, three heads, one tail, Third one, head, head, tail, head. Fourth one, head, head, tail, tail, head, head, tail, tail. Okay, head, head, tail, tail. Next, head, tail, head, 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 tail, head, tail. Next, head, tail, tail, head. The next, head, three tail. This is over. This set is over. With respect to H is the first. All in the experiment, H is first. Next, tail, head, 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 tail, head, head, tail. Next, tail, head, tail, head. Next, tail, head, tail, tail. Okay, then next, tail, tail, head, head, tail, tail, head, tail. Next, tail, 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 head. Next, all 4 are tail. So, total number of sample point in the given sample space is correct 16. So, see, observe here, the elements are not repeated. Why we write the tree structure? Because of this purpose. So, now very easy to write the samples point. That's why firstly better to write one side the tree structure, then only write the sample space. Observe this problem. So, this sample space for second PUC for 3 times and 4 times are very important. Okay, it should be repeated. Observe carefully. Next problem. Next problem, see, observe here. Next one, a die is thrown two times. A die is thrown 2 times. A die is thrown what? 2 times. So, for one time the outcomes are 1, 2, 3, 4, 5, 6. Correct? For one time. 2 times. So, how to write this one? The sample space is given by S is equal to first one 1 comma 1, 1 comma 2, 1 comma 3, 1 comma 4, 1 comma 5, 1 comma 6, 1 6, sorry, 1 6, 1 1, 1 comma 1 not, 1 1. What I do? I fix 1 in the first place. I fix 1 in the first place. Then start 1, 2, 3, 4, 5, 6. Okay. Next, what I do? I fix 2 in the first place. Start it. 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. This is very easiest method because this is very important. Not only 2 times, 3 times, 4 times. The problems are there in the second PUC. That's why the writing the sample space, the technique is very important. So 1 in the first place, we write the elements. 2 in the first place, we write the elements. The next 3 should be in the first place. 3 1, 3 2, 3 3, 3 4, 3 5, 3 6. And write the comma. That is very important because sets you know very well. Next 4 1, 4 2, 4 in the first place, 4 3, 4 4, 4 5, 4 6. Next 5 1, 5 2, 5 3, 5 4, 5 5, 5 6. The lastly 6 in the first place, 6 1, 6 2, 6 3, 6 4, 6 5, 6 6. Total number of sample space right here. N of S is equal to what? 36. Correct? N of S is equal to 36. Okay, a die is thrown what? 2 times. A die is thrown 2 times. Suppose if a die is thrown 3 times, how to write, sir? 1 in the first place, then start the number 1 2 1 3. We will see in the problem. Okay, a die is thrown 2 times. The sample space is given by total number of sample space are 36. Next problem. Next problem. A coin is tossed and a die is thrown. Very interesting. A coin is tossed and die is also thrown. A coin is tossed, the possible outcomes are head and tail. A die is thrown, possible outcomes are 1, 2, 3, 4, 5, 6. Firstly, what we do? A coin is tossed, then the sample space. Is given by. The sample space is given by S is equal. In that experiment, random experiment, what I do, I fix a head in the first place. Head and tail are the 2 outcomes of the tossing a coin. Head in the first place. Write the die outcomes. H1, H2, H3, H4, H5, H6. H5, H6. Tail in the first place. Write the outcomes of the die. T1, T2, T3, T4, T5, T6. Over? Yes. N of S is equal to how much? It is 12. Total number of elements in the given experiment, means in the given set S is 12. Correct? First what I do, I fix the head. Okay, then I write the outcomes of the die. Next, I fix the tail, then I write the outcomes of the die. Then total number of elements in S is 12. Next one. And an experiment consists of tossing a coin and then throwing it second time. Tossing a coin and then throwing it second time. If a head occurs. Full stop. If a tail occurs on the first toss. Then a die is rolled once. A die is rolled once. That also you know. An experiment consists of tossing a coin and throwing it second time. Means tossed it second times when if head occurs. If tail occurs on the first toss, throwing a die. Then in that the sample space is given by, you know very well, simply observe here, the sample space is given by, if I toss a coin, head occurs, once again toss the coin, head, tail. The possible outcomes are only headed, tail. First place if head occurs, once again we toss the coin, means throw the coin, headed, tail. If the first place tail occurs, throwing a die, what are the outcomes? T1, T2, T3, T4, T5, T6. Then N of S is equal to how much? It is 8. Total number of sample point in the given experiment is out 8. I think understand to write the sample space. Next one. Next problem. A coin is tossed if the outcome is a head, a die is thrown, if the die shows up an even number, the die is thrown again. The die is thrown again. This also you know very well. A coin is tossed if the outcome is head, a die is thrown. If the outcome is tail, that is enough. No need to continue the experiment. So better first what we do, write the sample space. The sample space is given by S is equal. Firstly I write tail because it should be the stop. It will not continue. If the outcome is head, a die is thrown. See, if the die shows even number, die is thrown again. For that what I do, H1, I write odd numbers firstly, H3, H5, because it will stop, it will not continue. Tail, it will stop, H1 stop, H3 stop, H5 stop. Once again, if shows an even number, die is thrown again. Then we write H2, 1. Understand? Write the 6 element, comma, I write below better. H2, 1. H2 is fixed, H2, 2, H2, 3, H2, 4, H2, 5, H2, 6. One even number is over. H2, 6. The next, H4, 1, H4, 2, H4, 3, H4, 4, H4, 5, H4, 6. Correct? 4 is over. H6, 1, H6, 2, H6, 3, H6, 4, H6, 5 and H6, 6. That stop. Complete the experiment. So these are the sample points. How many sample points are there? 18 plus 4, 22. N of S. N of S is equal to what? 22. N of S is equal to, see, observe here, N of S is equal to what? N of S is equal to 22. Next problem, one more problem. An experiment consists of rolling a die and then tossing a coin once rolling a die and then tossing a coin, correct, tossing a coin once if the number on the die is even if number on the die is odd coin is tossed twice. The coin is tossed twice. An experiment consisting of rolling a die and tossing a coin once. Tossing a coin once. If the number on the die is even. If the number on the die is odd, the coin is tossed twice. Okay. The sample space. The sample space is given by, you know very well this one, S is equal to. What we do first? If the number on the die is even, we take 2. So a coin is tossed only once. 2 head, 2 tail. Correct? 2 head, 2 tail. 4 head, 4 tail. Over. 6 head, 6 tail. Because only once. An experiment consisting of rolling a die and tossing a coin. A coin is tossed only once if the number on the die is even. 2, 4, 6. If the number on the die is odd, it starts from 1. The coin is tossed twice. The possible outcomes are head, 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 tail, tail, head, tail, tail. So 1, H, H, 1, H, T, 1, T, H, 1, T, T. Correct? Because the possible outcomes, if a coin is tossed twice, the possible outcomes are, if you not very well, write the tree structure. Very easy to understand. Number 1 is over. 3, head, head. 3, head, tail. Correct? 3, head, tail. 3, tail, head. 3, tail, tail. This is over. 1 is over. 3 is over. 5, head, head. 5, head, tail. 5, tail, head. 5, tail, tail. Over. So, how many elements are there? 2, 4, 12, 12, 16, 18. N of S is equal to what? 18. See, this is very important. Very important about the experiment. Okay. So, I think you better to solve some more problems regarding sample space in the first UC textbooks. Then only you are perfecting about to write the sample space. So in the probability, very important concept is how to write the sample space. That is very important. So that's why what I want to suggest to you, solve all the problems in the first UC textbook regarding sample space. I select only few problems. Okay, select only few problems. Okay, we stop the sample space. So one more tree structure I want to write. The tree structure is 52 playing cards. You know very well, I think all of you know very well the 52 playing cards. So 52 playing cards, so I write here 52 playing cards. Are divided into 2 parts, correct? 26 black cards, 26 red cards. So we divide 52 playing cards into 2 categories, 26 black cards, 26 red cards. Again 26 black cards. We divide into 2 categories, 13 spade, 13 club. Correct? 26 black cards. Again we divide into 2 categories, 13 cards are spade and 13 cards are club. Again, in the 26 red cards, we divide together 13 heart and 13 diamond. 13 diamond. So 52 we divide into two parts, 26 black cards, 26 red cards. 26 black cards, 13 spade, 13 club, 13 heart and 13 diamond. And each 13 set, that is very important. This is very important. Each pack, 13 set. So it is also category wise. See, observe here. One ace. This card we call it as alphabet card. In each 13 set, one ace is present. So how many alphabet cards? 4 alphabet cards. Numbering cards 2, 3, 4, 5, 6, 7, 8, 9. Numbering cards because 13. So these are called numbering cards. 2 to 9 numbering cards. One is ace. 2 to 9, 9 cards. 9 plus 1 is 10 numbering cards. Then remaining cards, king, queen, jockey, face cards. Face cards, king, queen, jockey. So in the each 13 set, 4 alphabet cards. How many face cards? In each set, 3, 3, 3, 3. How many face cards? 12 face cards. One face is king, second face is queen, and third face is jockey. These are all called numbering cards. These are all called numbering cards. This is about a 52 pack of playing cards. This is the tree structure for what? 52 pack of playing cards. Okay, up to this we stop. Okay, we continue the remaining concept, events and the definition of probability, then second basic concept in the next class. Thank you.